Okay, so the problem we're looking at today is the USACO 2020 January contest gold problem 2 of Farmer John solves threesome. So you can pause the video first and read through the problem yourself. Okay, I assume you read the problem. So basically what the problem is asking for is you're given an array A of at most 5,000 in size. And now you're given also Q queries. For each query you're given AI and BI. And for the sub-array of AI to BI, you're trying to solve the threesome problem in that sub-array. So what's the threesome problem? So the threesome problem for subarray is the number of triplets Si, Sj, and Sk where the sum of the three values is 0. So now we can pause the video once again and try to solve the problem yourself first. Okay, I assume you thought about the problem. So what are something that we noticed when we see this problem? Well, first of all, the first thing I noticed is that it's actually quite easy to find the number of triplets if you already know the first and third elements. Because it's just going to be the number of times the second element occurred between this first and third, which we can easily find what the second element will be, right? So that's basically my idea during the contest. So here's my in-contest code, which I could not receive full credit because I was stupid. But so basically what I did is I first found the number of triplets that exist for a fixed first and third point, and I stored that in the answer array, which I later got rid of the array answer, but it just means the number of triplets where you're forced to select I and J at the first and third point. And then since we're being asked not when we're forced to select, but only as long as the first and third point are all within a range. So it's not forced to select. So then we have to. I use two other array. LB means when the first point is still forced, but the third point is flexible, which means as long as the third point is less than or equal to J, then this triplet is deemed legal. But the first point is still fixed. And now answer R represents a true answer where the first and third point are both not fixed, like they're not forced to select. J just means the first point has to be greater than or equal to J, and I just means the third point has to be less than or equal to I. So this algorithm, it will give the correct answer. However, the space complexity is incorrect because now we need two array. Even after getting rid of answer array, we still need two array, LB and answer R, which each will need to have a size of 5,000 because n is at most 5,000. We need to have both of array have size of 5,000 by 5,000, which since we also need to store both of them in long 64-bit integer, and long takes 4 bits in space, the space complexity of this whole algorithm will be around 400 million bytes, which is greater than the 256 that USACO problem usually give you. So that algorithm can only receive credit for the first 7 test cases because n is less than 2,000 for those. So then how do we actually solve this problem? Well, the method that I came up with after the contest is the classic trick of throwing stuff onto the coordinate grid. So basically, let me call it drawing. So let's say CNT ij means the number of triplets that occur at point ij on no. So what I mean is let's create a coordinate grid where the x coordinate means the first element and the y coordinate means the third element. And every point on the coordinate you're forced to choose the x as the first and the y as the third. Meaning there's no flexibility. And now let's store that in array CNT instead of answer now because it's a different algorithm. So let's say now we have CNT array all found out because we already know how to do that. And now how do we find the answer when where the first and third elements are flexible, meaning we're not forced to choose them first and third? Well, how to do that is we can take the 2D prefix sum, right? Because think about it. If we're trying to find the all answer where the first element is less than 3 and the third element is also less than or equal to 3, it's just going to be the sum of all these points within this region, right? And then we're trying to find the answer since we're given both the upper bound and the lower bound. Let's say the question is when we're trying to find the answer between range, say 1 and 3. So then the first and third element both have to be less than or equal to 3 and greater than or equal to 1. So it's just going to be the sum of the points in this region, which we can also easily find in O1 complexity using 2D prefix sum, if you know how 2D prefix sum works. So this way, how does that help us? Well, now, since we're trying to find it using since we're finding it using a 2D prefix sum, we don't need two arrays. We just need one. We just need the answer R. And then we can find the 2D prefix sum in the n squared time complexity, which is permitted for this problem. And so this is finding the 2D prefix sum, and this is finding the answer for every query, which are both a 1 in complexity. And now you only store one array, which will give a 200, which will give, since it's long, 200 MB in the space. And it's solvable for this problem. So that's the first method, 2D prefix sum, which utilizes the classic trick of throwing numbers onto a coordinate grid. However, USACO official solution provided another idea for this problem, interval DP, which I probably should have thought about since we have an n of 5,000 and the query, there's at most 10 to the 5th power queries. I should have thought of interval DP because you just pre-process the answer for every single interval and then you report the answer in O1 complexity. That's kind of, it should be intuitive for me, but I was stupid during the contest. Anyways, Fij means the number of triplets within the range ij and not necessarily selecting endpoint, which means this is the answer for query ij. Like you're not forcing to select I or j, so this is the actual answer. And for just like any other interval DP, you have this transition formula, right? Basically, all interval DP has similar formula like this. However, we can't actually store the CNT. Even though we know how to find it, we can't store it because then it will be too much in space complexity. So we'll just have Fij temporarily be CNT first, and then instead of equal to this, we'll have it plus equal to this. So then we can get rid of the CNT, and our space complexity will be correct. So this is the USACO's official solutions idea of doing this, which is essentially achieves the same thing, but with interval DP. So now when we come back to the question today, the USACO 2020 January contest gold problem 2 of Farmer John solves 3-sum is there's two possible approaches of 2D prefix sum or interval DP, which I will be posting both codes down in the comments. And I hope after this video you know how to solve this problem, and I hope this video helped. Thanks for watching.